So here we have a solution that contains 3 different metal cations all at the same concentration. All of these metal cations form insoluble precipitates with oxalates. So all of these metals have insoluble oxalates. We're going to add sodium oxalate to the solution. When this dissolves, we're going to generate sodium ions and oxalate ions in solution. So the oxalate ion concentration is going to increase. And it continues to increase as sodium oxalate is added until the ion product is greater than KSP. And at that point, the oxalate is going to precipitate. Now we look at the dissociation reactions of each of these metal oxalates. We see them each are going to dissociate in the same manner. We have one metal cation and one oxalate anion. So when we look at the KSP value, we see that KSP is going to be equal to the concentration of that metal cation times the concentration of the oxalate. We can save ourselves a lot of time and work in this problem if we recognize the significance of the fact that all these metal cations are of the same concentration. We solve the expression for the oxalate ion concentration needed to reach a saturated solution, i.e. when the ion product is equal to KSP. Once the oxalate concentration exceeds that value, precipitation is going to begin to occur. So the oxalate ion concentration required to reach equilibrium is going to be the lowest for the smallest KSP value. So the answer here is calcium oxalate. It has the lowest KSP value of the 3. It's important to note that if the concentration of the metal cation were different among the 3 ions, you could potentially get a different answer. This is illustrated in the next problem.